Effects of alloying elements in steel material. The first one is manganese. जो carbon, the manganese content is 0.3 to 2 percentage. Maximum alloying elements of in steel is 0.3 to 2 percentage. So the effects is the manganese is a deoxidation and desulphurization of molten steel, minimize the harmful effects of steel. So manganese plus sulfur is the manganese sulfur is less harmful than iron sulfur. Okay, the MNS is less harmful than FES. So MNS is improve the machinability and wear resistance of the material, increase the tensile strength and hardness, increase the hardenability the material in steel, lower the critical temperature range in steel material, promotes the austenitic structure in steel material. So the manganese application in steel is particularly in the periodic steel. So up to carbon up to percentage 2% of manganese. So increase the high hardenability. Okay, is increase the hardenability in steel material is used for gears, connecting rods and soft material. And hard filled steel is so up to manganese content is 13% in steel material. So is the austenitic steel or manganese steel. This material is called for austenitic steel or manganese steel. Is high magnetic manganese austenitic steel is the excellent abrasion resistance and toughness material. Is the excellent abrasion and resistance and toughness material is used for mining, cement and railway industry. Okay, is application is the 2% of manganese is high hardenability is used for gears, connecting rod and shaft, and 13% of manganese is called austenitic steel or manganese steel is using for mining, cement and railway industries. The next is silicon. So what are the effect silicon effect in steel materials? So maximum silicon content is 0.3 to 2% in steel material. Is the effect is the deoxidizer and graphitizer, lowering aluminum melting point. Okay, lowering the aluminum melting point, increasing the fluidity in casting, altering the permeability. Iron plus silicon alloy has high magnetic permeability and low hysteresis effects, improving the steel grain structures. Iron plus silicon is silicates is has high hardness and wear resistance properties. MNS is improve miscibility and wear resistance. Okay, so presence of manganese plus sulfur in steel materials improve the miscibility and wear resistance of the material, improve the magnetic and electrical properties, enhance the copper alloy for strength and corrosion resistance, increase the hardenability, strengthen the low alloy steel and promotes austenitic structure in steel material. So this is the effect of silicon. This application is a silicon steel. Okay, up to 4% of silicon is the transformer core material. Okay, automotive components, particularly for IC engine valves. Okay, it's 3.5% of silicon and 8% of chromium. Electric motor, the silicon bronzes used for particularly for electric motors. Foundry application, silicon improves the fluidity, resistance to cord cracking and pressure tightens in the casting alloys. Okay, is particularly silicon for pressure tightens in tightness in casting alloys. Semiconductors application, doping silicon phosphorus is N-type or P-type semiconductors for electronics and solar cells. Okay, so particularly silicon used for semiconductors. So N-type or P-type semiconductors are particularly for electronics and solar cell applications. Next is a chromium. Okay, so content is 0.3 to 4% in steel material. So effects is chromium plus iron is hard carbide. Okay, is the formation of hard carbide is wear corrosion and oxidation resistance and high hardness, increase the strength, impact resistance and toughness to the steel material. It decrease the machinability. Okay, so chromium is decrease the machinability of the steel material, increase the hardenability, increase the high temperature strength, increase the hardenability. Okay, okay, increase the abrasion resistance properties of the material. So for applications for medium and high carbon steel. Okay, medium and high carbon steel. So 1 to 1.5% of chromium, Okay, is mainly used for shafts, springs, axles, gears, bearings, and metal rolling process. So martensitic and ferritic steel materials, so 12 to 25% of chromium presence, okay, in the particularly martensitic and ferritic steel material. So chromium present is 12 to 25% is used for high temperature application for steam turbines, fusion reactors, okay, is used for steam turbine and fusion reactors. Next is a molybdenum MO. So 0.1 to 0.5 percentage. So maximum presence in steel is 0.1 to 0.5 percentage. The effect is improve the grip resistance. Okay, increase the hardenability. Nickel chromium steels increase the hardenability, stabilize carbides, reduce the temper brittleness in nickel chromium steels. Okay, mainly for reduce the temper brittleness in nickel chromium steels. So application is high speed tool steel HSS. So retain hardness at high cutting temperature, drill bits and so application drill bits and milling heads, tabs and for cold forming tools, grip resistant steel. So, okay, resist permanent deformation under constant mechanical stress. Next, power generation equipments and high temperature pipelines. This is for power generation equipments and high temperature pipelines. Okay, so nickel chromium molybdenum with 0.5% of molybdenum MO in nickel chromium molybdenum alloy is called nickel chromium molybdenum alloy is for welding electrodes. Okay, is for manufacturing of welding electrodes. Nickel chromium molybdenum with 0.5% of molybdenum. Nickel chromium molybdenum alloy is a welding electrodes. Next, nickel. So maximum presence in steel material 0.3 to 0.5. Okay, in presence in steel material is effects is improve strength and toughness, increase the hardenability, reduce the critical temperature of steel, improve the resistance to fatigue strength, high amount of presence of nickel resist to oxidation at high temperature. Okay, reduce the miscibility of the steel, strong graphite forming tendency. Okay, this is mainly for strong graphite forming tendency. So application is carbon with up to carbon with up to 5% of nickel is mainly used for crankshaft and axle applications. Chromium nickel steels for gas carbureting applications. Chromium nickel, so up to 0.3% carbon is used for connecting rods, gears, shaft and axles. Chromium nickel, so 18% of chromium and 8% of nickel is used for austenitic stainless steel. Okay, is the austenitic stainless steel. So next, vanadium is maximum presence is 0.1 to 0.3 percentage in steel material is effective strong deoxidizer and forms carbides, improve the fine grain size. Okay, so presence of hard carbides is wear resistance and resist tempering scavenging actions to produce a clean and inclusion free steels, raises the softening temperature of hardened steel, enhances an alloy strength, hardness and variations of the steel material, grain refinement, reduce the average grain size of alloys, mainly for grain refinement, phase formation, okay, promotes the formation of various phases. Okay, so vanadium in steel material. So main application of the vanadium in steel is vanadium 4 Cr4Ti is for fusion reactors, mainly used for this type of alloy elements, mainly used for fusion reactors. Vanadium alloys with chromium and titanium for high temperature structural applications. Presence in high speed steels. Okay, pearlitic chromium steels. Okay, is called pearlitic chromium steels. Titanium is the effect in steel materials, strong carbide forms and increased strength of steel. Prevents formation of austenite in high chromium steels. Prevents the grain hoarsening. Act as a grain refiner. Okay, is the prevent the grain hoarsening. Act as a grain refiner. Reduce the martensitic hardness and hardenability in medium chromium steels. Titanium in stainless steel prevents the precipitation of chromium carbides. Okay, implants biocompatibility, non-toxic, implement to human bone tissue and high temperature application up to 400 degrees Celsius. So what are the application for titanium in, effect in steel is carbide stabilized in austenitic stainless steel. Okay, aerospace and medical implants and automotive parts applications, particularly titanium 6 aluminum 4 vanadium aerospace and aircraft industries used for mainly commercial pure titanium grades is high corrosion resistance and biocompatibility. Alpha and alpha beta alloys is for high pressure hydraulic lines. Use beta alloys mainly used for turbine components. The tungstens, okay, is the effects in the steel is promotes hard carbides. Okay, is promotes hard carbide in steel. WC, W2C, Fe4, W2C. So it leads to wear and abrasion resistance on tool steels. Reduce grain growth but increase the grain refining effect. Okay, reduce the grain growth but increase the grain refining effect. Retards the softening monatonicity during tempering, gives a horn red corners and maintaining strength at high temperature applications, rises the softening temperatures. So mainly used in application wise, high in HSS tool, high speed tool steel, permanent magnet steel material and die steel material. Tungsten with nickel and iron is high density application. Okay, tungsten with nickel is mainly used for high density application and radiation shielding purpose. So aerospace and military applications, pure tungsten is used for filament for light bulbs and electrodes for welding. Okay, electrodes for welding applications. These are the effects of alloying elements in steel material. Okay, is the first one is manganese. Okay, effects and applications. Silicons effects and applications. Chromium, molybdenum, nickel, vanadium, titanium, tungsten material. Okay, is the effect, what are the effects in alloying, effects in steel material. These is the alloying elements effects in steel material.